Maclaurin number 2, sine of x. Again, derivatives are not that hard to find, and we're going to see there's some looping involved. And in addition to that, when we plug 0 into our derivatives, we're getting some nice values. So here we go. Sine of x is our function. We derive it, we get cosine. We derive cosine, we get the opposite of sine. We derive the opposite of sine, we get the opposite of cosine. We derive the opposite of cosine, we're back to sine. All right? And then we just loop it all over again. So what do we have to do with our function, our derivatives? We've got to find their values when x is equal to 0. So when we do that, sine of 0 is 0, cosine of 0 is 1. Negative 1 times the sine of 0 is still 0. Negative 1 times the cosine of 0, negative 1. Sine of 0, back to being 0 again. Let's build our series. Sine of x equals, we're going to write this the long way out, and then we're going to simplify it to the short way that you're looking to memorize. All right. So we start with f of 0, which is 0. So the sine of x is equal to 0 plus. Now we go to our first term. All right. So we have f prime of 0 times x. So we have 1 times x. All right. Plus. Now we go to our second term. Or rather, when n is 2. That means we're looking at our second derivative. And we see again that we have 0. So we have 0 times x squared over 2 factorial. Now to our next derivative, negative 1. All right, so minus 1 times x cubed. All right, over 3 factorial. Okay, and then we go to our fourth term, and we see that it's 0 again. All right? And then we go to our fifth term. Well, the fifth term is going to be back like the first term. So it's going to be 1 times x to the fifth. All right, so plus 1 times x to the fifth over 5 factorial. And this is going to continue onward. We can see a pattern forming here. Let's simplify this without the zeros and all the ones. So sine x equals, that's x. Then we have minus x cubed over 3 factorial. And then we have plus x to the fifth over 5 factorial. All right. What's the next denominator going to be? Yeah, 7 factorial. It means we're going to have x to the 7th. Positive, negative, positive, yes, negative. It's an alternating series, all right? Plus x to the 9th over 9 factorial. Minus x to the 11th over 11 factorial. All right, and if you actually graph this on your calculator, you're going to see that the more we go out, the more waves that our series is going to match up with the sine of x. It's really cool if you took sine x in your y1 and you put this into your y2 and you just keep adding terms, you're going to see one function just map right onto the other one. All right, what's our general term? All right, well, in order to get our general term, we need the alternating happening. All right, so we're going to have negative 1 to the nth power. And the reason why is because we start with n being equal to 0, and we want our first term to be positive. So by having negative 1 to the nth, that means negative 1 to the 0. That's a positive term. All right, then we have x. Now we need it to go up by 2's, and the first one to be x to the first power, because there's an unwritten 1 right there. So we actually have an exponent of 2n plus 1. All right, and we're going to divide by that same 2n plus 1 factorial. All right, and that will give us the general term for the sine of x. All right.